Hi everyone, welcome to nithya.org Igniting Innovations. So we are in the Kubernetes Deep Dive Part 3 section, Building Fault Tolerant and Resilient Container Cluster. Today, we are going to see many things about Kubernetes cluster on Google Cloud, and we are going to put our hands on dirty towards how to create services, how to create deployments, and how to play with DNS and many more. Please stay tuned. And if you want to access the source code, you can access via github.com/nithyananda/kubex. And also I am suggesting to visit nithya.io or nithya.org for further information. The agenda of the demo is Accessing Kubernetes Dashboard and their sections. So here we are going to explore more thing about what kind of a dashboard which is Kubernetes offering for us. And then we are going to run one of Standalone Sample Ecommerce Application which is created by me. It's a small Angular 2 app. And also we are going to see how we are going to run that app into our local Docker engine. Then once it's tested locally, we are going to push the same image to the Google Container Registry, that is gcr.io. Once that image is pushed, and we are going to play with many deployments and how we can leverage the images in many forms. So via that we are going to understand many of the commands for kubectl. Then we are going to deploy the application instance from that pushed image in Google Container Engine cluster. And then also we are going to explore what is called ReplicaSets and how it's helping us for resilency. And also we are going to create internal and external services to access the services and pods internally from the cluster as well as from outside world using internet. And also we are going to explore some DNS features which is service offering, and also access our services using our internal DNS names. Everything we are going to see in this demo. Please stay tuned. How to access the Kubernetes cluster dashboard. Let's see. To access the Kubernetes dashboard, we need to have some information from the cluster, such as like endpoint, username, and password. For that, I'm going to issue the command gcloud container clusters describe our cluster name. Our cluster name is Nithya Ivor Demo -cluster. Yes, we got the information from that cluster. So here, if you see that, what is our cluster CIDR block and what is the time which is created, the cluster is created. What is the endpoint? This is an important thing which we needed now. And what is the username and password to access the dashboard? And also it having multiple information. As of now, the cluster is running. And what is the version we are using in Kubernetes binary? And which data center we have hosted our cluster, Asia Northeast 1A. But reading it is very cumbersome. So what I'm going to do is I'm going to grab that separately. Grab endpoint and username and password. Yes, we got everything. So I'm just copying this and going to the web. So I'm just issuing that https:// IP name, just give it. Yes, there is consent screen for self-signed certificate. Go ahead. Yes, we are able to access the API, and I'm going to give, we need to access our dashboard, so we need to give /UI. Yes, we are able to access the dashboard. And what are the things we are seeing over here? So the first thing is, it's telling there is nothing to display here because we didn't deploy anything in our cluster. So if you see that, we can explore all the things. So if you see the admin block, the first thing is namespace. So namespace is nothing but the logically grouping your pods. So there are two namespaces available. One is default, another is kube system. So what does it mean by kube system? Kube system is nothing but it is a namespace dedicated for Kubernetes binaries, which is running as the pods. So we will explore later and what is the kube system and all, and what are the nodes available, and it's provision as a part of the Google Cloud Container Cluster. So we have provision 3 cluster, which we created in last video. And is there anything persistent volumes? What is meant by persistent volume? Persistent volume is nothing but it will persist even if your the system down or containers down, pods down, so you can access your content from here. And so as I said, there is a namespace block, so you can select 2 namespaces, default and kube systems. Let's come back. And deployments. So deployments the mechanism to understand what is the sequence, what is the pattern we have deployed the application, and how can I identify with a particular ID. So every deployment will maintain that deployment ID. So, and you can roll back, you can update, you can scale using this deployment ID. Everything will do it from the deployments. We are going to see many things in deployments. And replica sets. Replica set is nothing but it is going to take care of how much replicas I need to spin and how much things I want to control myself. Okay, I want to spin 5 parts now, and I want to spin 10 parts now. That is going to be taken care of replica sets. And replication controllers, this is the guy who is managing the state of management. So that means it is managing so the desired state, whatever the desired state we have requested, what is the requirement for we have requested to your Kubernetes cluster, it is going to maintain. For example, hey, please deploy 12 pods with this image and this is the port number. So this is going to maintain that the configurations at any point of time, it is not going to change it. And also, even if you kill or stop any applications, automatically that application will be come back because of the replication controller. Daemon sets. Daemon sets is nothing but the guy who is running in a background and then it is going to watch, like a log mechanism, like you want to monitor something. So these are the daemon set, like I want to monitor my CPU and logs. Everything will be done by the daemon sets. And the pet sets, what does mean by pet sets? This is a newly introduced mechanism to maintain the stateful pods. Stateful pods. Actually, the real idea behind microservices, you should be stateless, but that we cannot avoid some application needs to maintain the state. Like I want to maintain the persistent disk, and that persistent disk will always shared by multiple guys, and I want the state management. That's what all things about. That's called pet sets. So this is the web, and it is an actually beta. There are so many limitations applied over this. And jobs. So this is a guy who, suppose you don't want to run a like 24 hours pods, because it's not making it, because I want to just count the numbers for like 100,000 records. So once it's done, I need to stop it. So these are the things you can print as a jobs. Jobs is nothing but to accomplish some task in a particular period of time, and it has to be written automatically. So that's what job does it. And pods, very important concept of Kubernetes. It's pods. It's a minimum and unit of deployment. It's a minimal deployment unit. So whatever we are doing it, everything in terms of pods only. Even if you call ReplicaSet, even replication controllers, and everything will run as a pods only. And even Kubernetes service as running as a pods. So you will see it in action. And there is another thing called service and ingress. What is meant by services? So let me tell you what is the services. Services nothing but it possesses two shapes. The first one is it is going to work as a Kubernetes for work as a load balancer for internal pods. So whatever the pods you are hitting it, so that is going to take care of distributing the load to the entire pods. The another mechanism is you can find the pods via DNS internal resolution names. So like for example, I have spin that like order services. So I can get that order services in terms of order service as a resolution name, or order services dot default dot service dot local. So you can find via DNS names. You are going to see that in action. And ingress is the mechanism to ingest the things towards inside the cluster. That is also we are going to see it. So next is persistent volume clients. So it is actually going to act as a storage, and this so you can attach some volumes from the Google disk, Google persistent disk, also AWS, EBS, all the things is going to come under this category only. And the main another thing is configuration management, that is configs. If you want to share some details about from one pod to another pod, or you want to mention your somewhere you have to store the details in the cluster, but my container want to access the things. So there is two mechanisms available now. One is secrets and config maps. But secrets is only for to maintain your tokens, username and password in a file or something. So it is actually going to be encrypted and stored somewhere, and you can get it back via your YAML file or in containers code. Everything you can get it from secrets. That is to maintain your secrets. The name itself, it's stressing the word is called secrets. Another is configuration maps. It is same like as secrets, but it is not meant for like storing username and password. Config maps actually it is a key value pair which is going to show across that it can be accessed via entire cluster via that key pair value. So if you provide a key and it will give a value, so that's a key pair value you can mention in your YAML file, and the same thing like that, but it is not maintained not required to be manages secrets, correct? So that's what these are the main important concepts which you can see and see the aggregated results in the Kubernetes dashboard. Before jumping into the another action, so I want to tell that as we speak about namespaces, what is this guy is actually, as I told, kube system is nothing but this is a namespace which is controlling that all the system pods. System pod means let me explain what are the things are the system pods. So go and see that pods, correct? So if you see that previously in default this is actually for customer pods, and if you see that nothing is showing, is it? So but if you go to the kube system, you can see the numerous pods, which is these are the pods which is acting as a backbone to run the entire cluster. That's what actually is doing it. And even if you are seeing the dashboard also running as a pod, you can see that. So Kubernetes dashboard 1.40 uses that too. It's running in 23 minutes. So these pods actually running. This pod is it's providing us a dashboard, And the first three parts, if you see that fluentd cloud logging, it's nothing but it is allowing us to ship the logging from every nodes toward the master. Even it is allowing us to put with the stack logs in Google Cloud, as well as the Cloud Watch or anything. You can control it via this cloud logging mechanism. So it is shipping that, it is just shipping the application logs towards that, and even system logs towards that Kubernetes cluster or anything wherever you subscribe. So you can forward this logs. Another main thing is called Hipster. Hipster is nothing but a resource like monitoring details aggregator. For example, so every pod might have that CPU memory, CPU and RAM memory, as well as that network file system, and how many requests is going. Everything you can get aggregated from the Hipster. Hipster is nothing but it is getting the information from the C advisor via the kubelet services. So it is just a aggregator. Even if you see in the dashboard usage history of CPU of entire cluster, memory history of CPU and entire cluster, everything is actually getting by that Hipster only. So you can see in right hand side CPU cores, memory, everything is actually retrieved by Hipster. And another two important parts called kubedns. What is a kubedns? Kubedns is nothing but is a DNS name servers which is running as the pods. So it is a backbone mechanism of resolving namespaces for service and pods. So that's what you can able to the services can run act as a load balancer kind of thing. So that's what kubedns provides. But Kubernetes is not in a single man. The guy, actually there are three containers are running inside that pods. One is kubedns itself. The second is actually DNS mask. Third is healthy. So we will explore more in the kubedns separate session. And another thing, so another important thing is called kubeproxy. The kubeproxy is actually it's running on every machine. You can see the 2, 3, 4 things is running in a separate thing. Why it does? Because the kubeproxy is acting as the front runner for giving us services to the outside world, as well as even internal, whatever the load balancing and whatever that the firewall things, security things happening via the kubeproxy only. So it is acting as a proxy who want to interact with the services. That's what is happening with the kubeproxy. And these are the main important components of the Kubernetes ecosystem. And also it is running as actually a service. And there is another thing called HTTP backend service, which is also what responsible for anything HTTP action is going behind the scenes. That is also this one. So this is taken care of with this pod only. So these are the important thing which you understand it. And that's all about the Kubernetes dashboard. So even here you can create the pods, you can create directly. So you create, click the application, you can specify the app details below, like what is the app name, and what is the container image, what is the how many number of slots you want to spin, do you want to spin as this any services. The service also acting as internal and external. So these are the things you can give it. Even you can provide the labels. I will tell you what is the provide labels, what is the namespace you want to use it to spin it, and what is the requirement of the CPU, what is the requirement of a memory, and do you want to run any commands inside it whenever you spin the pods, and do you want to spin run as a privileged pod, and do you want to provide any environment variables. Everything you can specify here, but it's not scalable because admin cannot spin it, but once a while so they can do it. But the best way of doing it, you have to use kubectl for automation to automate the things. So that's what actually this is all about. So you can spin, and also if you want to, and also you can control it also. So for example, so I'm going for the spots. You want to control, you want to stop, you want to delete it. Everything you can do it via here. You can delete, or you can view the YAML file. What is the YAML file which is there, how they spin this YAML. So everything it is accessible. You can update it, you can copy and paste it, and you can use it for your own purpose. Everything you can do it via Kubernetes dashboard. So that's all about this accessing Kubernetes. And for entire demo, we are going to use it to use this dashboard to see what is the status of our the cluster. So everything we are going to access it. So please stay tuned until for the next demo. Now we are going to see how to run the sample application which I have prepared called DIMusic. It's a small standalone web application. It's an e-commerce application in a local Docker engine. To play with the Kubernetes cluster, we should have some sample application and which should support to try with all aspects of Kubernetes cluster, which will not help us just like empty BusyBox or Nginx servers. So we should have some sample application which is related to real-time world. So that's what I have created, one Angular 2 application that is hosted in that is actually I have put into the GitHub. So you can see that there is a repository called github.com/nityananda/DIMusic. So we are here only. And there are two things which is I put it. One is standalone web and another is microservices based web. What is meant by standalone web? Standalone web is nothing but it doesn't interact with any other services. It will do all the work by itself. So it will take the data from their own services and it will show the picture from their own directory and everything. That's called standalone web. Another is microservices. This is a little bit complex because we have one web server which is created in Angular 2 app. And then it will interact internally with all the services and it interact with each other, and it will resolve the DNS itself. So all kind of a complex scenario, we should have some application like this. So I have created a both, but as of now for this demo, we just concentrating on standalone web. So if you click here and given, I have given the nice readme file, how to download it and how to build and how to run the server in locally. So please try at your own time. And as well as if you see that I have put already a Docker file. So if you build that Docker, once you build that application, and you will get there is a folder called dist folder. This distribution folder that has to copy with this. So you have to successfully build and as well as your build the Docker file using this source. So, and for simplicity, I already built it and push it into that Docker hub. So we need to go to the hub.docker.com and please click explore. And these are the official repository which is listing here, but I already put in my username. That's called nbabu sundaram. So click enter. So you will see different images, but we are not interested in that. So if you have free time, you can play and separate images. But as of now, go to the second page, and that second page you have that image called nbabusundaram/DIMusic-standalone. I have missed that D over here by mistake. So click over here and grab that image name and go back to your command prompt. And we are going to pull that the images using Docker engine. So, but first of all, you should have Docker in your system, but it will already have if you use my Vagrant. So -- version, yes, we have a Docker, and see that is there any images which are already there. Docker images, there is no images over here. So images is nothing but it is a packaged your application and application environment and system libraries. These are three things. It's called as image. So, and also packed as a unit, packed and uniquely identifiable binary that you can say. And so now we are going to pull that Docker images which we copied now, and also please use tag called v1. I don't have that naked image without version, because it will make sense, because if you maintain the version you can identify what kind of binary you have pushed into that image. So that's what I'm maintaining the version. So hit enter. So what it will do, actually it will go and talk to that Docker Hub and will pull that images. It will take little bit of time according to your bandwidth. So this image is actually around 200 MB, that is even lesser than 200 MB. So you please download it, because we are going to play more thing with it. So now it is extracting and it's going to pull it. Yes, we got downloaded the new image. Now you issue the command docker images. Yes, we have that images which is downloaded perfectly. So you can see that, and also the size of the image is 189.1 MB and it's created 3 days ago, and then image ID is over here, and what is the tag, which is version, which is v1. So now we are going to run this image in our local Docker engine. So before that, you check it, is there any containers running? Docker ps, nothing. Docker ps -a, is there any killed containers? No. So it is, everything is perfect. Now I'm going to run the container using docker run -d -p. So I'm going to port forward it to 8090, and I'm going to put it 80, which is a container port, and the image name. So image name is what we call it. Paste it. Paste it and b1. So Docker is running successfully. You can check it using docker ps. Yes, it is running successfully, and we got the container ID also, and also here we can see it. So the port is running an 8090 on host, and container port is 80. So we should able to access this application inside the host. So you can see curl http localhost 8090. So yes, we got some output. So you can see that there is a DIMusic company, and you can see it's an Angular app. So you can see the component called app root, and loading is the temporary message. This where all the contents is going to get loaded, and this is actually a console mode, correct? So but we need to see in a real browser. So you can try with two things. You can install links or e-links kind of a browser, so you can see it, but that is also not going to look good. So we are going to see in browser via port forwarding from Windows machine. So what I'm going to do is, I am in Oracle VirtualBox, and I'm clicking, because this is a running machine. I'm going to clicking and network, and I'm going to access port forwarding it. I'm going to put that rule called my Angular app, and port is 8090, and guest port is 8090. So I have mentioned the port. Now you go to the browser, and let's try to access it. Localhost 8090. Yes, awesome. So that this is the DIMusic app which I have explained, and it's nothing but it's a fictional company which I have created with my kid's name. D is for my son, the first letter of my son, and I is the first letter of my daughter. So it's called DIMusic company. And here it is a data driven application. It's not nothing, it's a not simple HTML, because you can see that there is a new which is coming from that Angular data, and as well as all the images is coming via the Angular routes only. And here you can see that. So for example, I'm going to order this 13 inches, click add to cart. You can see the product 13 inches has been successfully to the cart. Even you can go for Hollywood Undeed. So this is actually assembly work by Angular app, and also this app is actually a mobile first, so it can automatically can do with the help of Bootstrap, and you can see in a mobile also. So I have put all the efforts to make it good. Fine. So now we have running. Now you might have a doubt whether it is running locally or in a container. So I'm going back and I'm going to kill that containers. Let's see. So I'm going to kill it. This guy, docker kill. Okay. Now I'm going back. Check it. This is supposed to not work. Yes, it's not working. I'm going to start it back. Okay, started. Let's see, go back and it. So it's came. So it's working from the container only. So it's working awesome. So we are able to successfully pull the images, and we are able to run the images in locally. So I'm going to kill it. Okay, this guy. So now we are cleaner again back. That's all for this session. Thanks. Now we have a sample application running locally. The same thing we need to run in Kubernetes cluster. For that, we should push these images to the Google Container Registry, since we are using Google Cloud Kubernetes Container Engine. So what we are going to do is, now we are going to push our local images to the Google Container Registry. Let's see how to do it. Now we have running successful image and container locally. So see that in local images, we have the images. And now, so we should push these images into that Google Container Registry. Why? Because we are using Google Cloud, and to push it, it needs the image should be tagged in the particular naming conventions. Even though if you see the existing image, it is follows the naming convention of Docker Hub. See that the first part is actually naming convention, because it is a login ID for the Docker Hub, and this is our custom name and tag. So if you have this naming convention, then only you can push it to the Docker Hub. Same way, you should follow some naming conventions for Google Container Engine Registry also. For that, we have to use Docker tagging. So I'm going to use Docker tag, and I'm going to grab this image and v1, and then I'm going to mention the naming convention called gcr.io, that is Google Container Registry, and we should have project ID. That's we already set it up in the previous earlier videos, and and Nitya IO, sorry, that is a project ID. Then I'm going to name it called music web. Hit enter. So if you see Docker, again I did one mistake, so I need to mention v1 also. So now we will have three images. One is with latest, one is with v1. So I'm interested in the v1 thing. If you're not giving a version, so it is very cumbersome to control the versions. So now I have tagged as a v1. Now we need to push these images using gcloud. So how to do that? Gcloud docker push, push what we named it, gcr.io /project id /DIMusic web v1. Correct? So it enter. So it will take a decent amount of time according to your network. So it is preparing now. It is it started pushing. So it needs to push around like 190 MB. So until that, I'm going to freeze the screen. Now we got pushed that images to Google Cloud. So successfully, that's what we are getting, the digest SHA IDs, and then what is the size of that image. Everything is coming. So go back and see that whether that the container is having the image. So I am inside the container registry. So I'm just refreshing it. So we got DIMusic web in the place, and we got the ID which we mentioned. You can see that there is a ID 49092C76. So it is matching with this here. So it is the latest things which we pushed. And if you see that the 3 days ago, this is actually parent image which is created. That is a Docker images. You can see that here Docker images. So at the age, if you see that there is a 3 days ago, that's what it is telling, that when in the base image is getting created, it's just tagged. We have just tagged the images. That's what we are seeing this thing. And we got the tag, and you can mention many tags also along with that. So it's up to that things. And you can see the pull command also, how to pull it. So you can copy and paste it. So automatically you can download from anywhere, but you should have that the credentials to push the images, because it's a private registry for us. So now we are able to successfully push the images. Now we have successfully pushed that our DIMusic app into image into that Google Container Registry. Now we are going to deploy the same into the Kubernetes cluster. Let's see. So to deploy the application into the Kubernetes cluster, you can approach in two ways. The first approach, and the best approach, should be using a YAML file, because you can declaratively manage that configurations in a proper way. So if you see our GitHub repository, I put already some configuration over here in the Google Cloud. In the client folder, there is a configuration section. The first you have to see that called DIMusic YAML file. So this is the way you can deploy your application using deployment kind. So the kind, there are many different kind. You can deploy via pod. So this is the one kind which will create the naked pod and without any control of replications or something. So, and this is very rarely used, because if you want to maintain a single pod for entire node, you can use it and separately, and then you don't need any load balancing or some stuff, and you can use it a pod. But most things you will do, like you need some state management, you need some replica management, those kind of things. And also you need to make sure that how the continuous integration will be deployed. Everything you need to make sure that way. You should not prepare the kind pod, but it is actually internally it is going to use the pod things only via the API, but you don't require to use it. The second thing is called replication controllers. So you can use this way. This way you can maintain the replicas via deployment. But the thing is, still this will create that, but you don't have that the control over the deployment. What is the deployment ID which happened at 12 o'clock today? 3 o'clock today, like that. You don't have any control, and you cannot roll back easily, because it is going to create separate functioning in silos. So the best way to do it, and deployment, that isn't actually in beta, but it is going to be the deployment model. Okay, so that's what I'm going to use, the deployment kind. And here if you see that, first of all, you should understand what is the YAML structure. So YAML is actually, it's a very explanation is two different. What does one YAML is a YAML at another markup language, and you can say another way also. YAML is not a markup language, so it is a YAML is contradiction, but that don't bother about the name. It's maintaining the hierarchy with the tabs. You can see the controller, you can see that it's hierarchy with this, the tabs with the spaces, correct? So one was maintaining the two dots. You can see that different the hierarchy via the spaces. So you can use either tab or you can use either spaces. So you should maintain that uniqueness to while doing it, and that's way it will know the hierarchy of like a template having a metadata having a labels having that key pair values like that. So metadata, so the first important thing, you should name your deployment. So that's why here it's called DIMusic YAML. So I just put that because I want to know uniquely this deployment happened via YAML file. That's what I put a DIMusic YAML. And how many replicas you want it. So as of now, I'm going to maintain only one because I'm going to take separate session for that. And you can see that once you deployment will have the template. What template will have it? And template also will have a metadata, and you can maintain the labels over there. And labels is nothing but, so I have a separate session for labels, but still the labels is nothing but a key pair value, because via this you can access the resources, like list the resources based on this label, and also you can so this is and you can load balances using these labels, and so much opportunities there to understand via your services. So this is just a key value pair. You can maintain as much as label you want it, and your template should have it spec will have the container information, which is like what is the container name, what is the image I need to fetch it, and what is the port which is executing via the container. That's what actually it is doing it. So you should maintain, and there are so many parameters you can put it in that, but it is a very thin and lean configuration. So I'm going to use this to deploy your application. So how to do it? So go back to that, and we are going to use the unit called kubectl. So I have a separate session for the kubectl, but I'm going directly to explain it. So kubectl have that many functionality to create that thing. So if you hit enter, like -help, you can see that there are numbers, and the main thing we are going to use create method. So create method is that create a resource by file name or stdi1, standard input output. So now I'm going to use this to deploy our application. So what I'm going to do is, so I already saved the images replica1 and run this parts. So now I'm going to use it kubectl create. I'm going to use a file, use -f, and then my file is sitting at /background /configuration DIMusic YAML. What is that name of that part is DIMusic.yaml. That's okay. So I'm going to hit enter. So it is going to create the deployment for us. Once you hit enter, and make sure you should have the default credentials, which is already set it up in environment variable. So now we got the deployment created successfully. So you can see that using kubectl get deployments. So you can see that DIMusic YAML, and what we are asked, that is a desired count is 1, and what is the current count, that is also 1. So that means all the container pods are running up to date, and one is available and running, correct? So now you want to see that how the pod is running it. So now get pods, kubectl get pods will list the pods, all pods, which is whether it is running or killed, or it is having some errors. Everything will be listed by this. So you can see that the pod naming conventions, you can see that this is the pod name which we asked, but that it's having that some unique ID which is attached with the pod. What is that? So that ID is nothing but a deployment ID. So using this only, you can do many things in automation, like you can roll out, you can scale in, scale out, all the things. It's using this deployment ID only. So it will be very useful for the automation, for the CI/CD purpose. So now that is running fine, you can check it. The pod is running perfectly in a dashboard. So go back to the dashboard and see that now there is no pod. You just refresh it, going back to something and coming back. You can see that the pod is running, and it is running on which machine. So you can see the pod details and go to the nodes, and one of the node is going to run. So how we are going to understand it? So go back, do that kubectl describe pod name. Just take it and pod name. So you can see that, so it is going to give so much information about that, what is a pod and where it is running. So you can see that the name is this name, and it is running on this particular node. You can see that S4KR, and the IP of that node is 146.0.2. So, and these are the labels which we set it up. App equal to DIMusic YAML, and then template hash also it set it up by automatically, version equal to v1, and the status is running, and the state and the IP of the pod. That's what the beauty of the Kubernetes network. So it is using overlay networking, and it is going to give every pod will have one separate IP. So the IP of the pod is 10.84.0.1. So this is fetched from CDR block from container cluster. So while describing the container, you might see that IP range of CDR. So that's what you got that, and it is running on this. The controller is using a replica set of this one, because even though we are running only one, but still managed by replica set. And you can see that this is the history of how your deployment happened. So you can see the first thing is it is scheduled properly. So it's successfully scheduled, assigned. So this is happening via our Kubernetes scheduler. That is running in master. The kube scheduler is doing this work, and the next thing is it is actually successfully pulled. So you can see that, and it is already presenting on the machine. So it is successfully pulled, and it's created the Docker container, and then started the Docker container. That's what this is the container ID. So everything is actually we got because of that describe kubectl pod. So, and so if you can go and back and check the node, that's our S4KR. So you can click it, and you can see that in the pod list, this pod is running. This DIMusic YAML 1897, which is actually scheduled just now. And the cluster IP for this pod is actually 10.84.0.1. It is a container pod IP, and you can see that there is nothing is happening. It's every CPU cores are free, and it's a 0. Correct. So now you are able to, and you can go and click. Even though you can see that what is the CPU history, what is the memory usage history, all the things you can see it, and even you can get that how to create the pod manually using YAML file. So for example, you can go and see the pod, you can click it, you can delete, or you can even see the YAML which is created by this. So the basically end of the day it is going to use pod YAML only. So this is what actually mentioned all the things. It's on so much extra information which is available to us. And yes, so click cancel. So we are able to successfully deploy the pod in Kubernetes cluster, and kubectl. And another thing you should understand, the Kubernetes, that the deployment is controlled by ReplicaSets. So you can see that kubectl get rs. So you can see that is also desired count is 1, current count is 1, and ready is 1. So that's what's the state management. Even if you kill that pod, For example, I'm going to kill this pod, whether how the resilency is happening with this. So I'm going to kill that kubectl delete the pod name. Okay, I don't know the pod name. Okay, get pods. So both are same, so I'm just afraid. But see, this pod name actually doesn't have that deployment ID, which is along with NUI4G. So I'm copying it and I'm going to kill it. kubectl delete the pod. So it's telling pod is got deleted. So how the resilency will work? Just go and check it. So now that I'm going to see that what is the RS is telling it. See, now also it is telling desire 1 and ready. It's amazing, is it? It is actually came back. So now you can see that kubectl get pods. See, it came back with a different ID called WRL6WL, and here you can see that NUI4G. So that's the way of a replica set is working. So it's always maintain the state of whatever we asked, because you have asked over here, hey, I need to maintain always that one replica. So this is what actually the state management done by the replica set. So it's helping us for resiliency. So even if it's your pod crashed, it automatically will come back to your node. That's all for this demo. So we are going to see in next demo, which is explaining what is called services. Now we have successfully deployed a DIMusic app into the Kubernetes cluster in previous video. Now we are going to expose the DIMusic app as a service. So the service may be, there are two types of service. One is internal service, another is external service. What is an internal service? The internal service is only used inside the Kubernetes cluster across the domain. And the external services, the services will be exposed outside the internet. So anyone can interact from outside the world, can communicate to the services which is running on our Kubernetes cluster. So we are going to see both how to access the service, how to create the services, how to expose the services. So now there are two ways to do it. So let's see in action. Now we have successfully deployed our application into the Kubernetes cluster using a YAML configuration, and now we have to access the application using a service. Service is nothing but it is just going to act as our proxy. That means if you are accessing, it has to load balance your stuff behind the scenes. So service is acting in two phases. One is it is acting as a load balancer, another is it is going to act as a name resolver for us using kubedns. So you can access via that namespaces. So to deploy the service into the Kubernetes cluster, first check with the Kubernetes YAML file, which is I put it in DIMusic service YAML. Here you can see that I have mentioned the kind is called service and the meta name called same DIMusic as YAML as like the deployment name, because it's very easy to maintain, both are same names. And the main important part of the YAML file is this one. It's called selector. The spec which is telling it selector. How to what cases what cases I need to select the list of pods, which is I need to forward a request to them. It is based on these two things only. It is based on the labels only. So selectors and the labels are very correlated. You can see that the first, while creating deployment, we have mentioned the labels called app equal to DIMusic -YML and version equal to v1. I mentioned the same thing over here. Selector equal to app equal to DIMusic YAML and version equal to v1. But even you don't require to have mention all the labels, but still it is very useful to select this particular service is only to select that this particular pods which is running version v1. because that way you can have many services. So if the request is coming for version 1, you can distribute the load to that across the cluster pods which is only running version 1. So you can maintain the version negotiation, and you can deploy multiple version in different and also you can deploy different services for that. So it is allow us running multiple version at the same time in Kubernetes cluster. So it is very important. The label and selector are very close related, and then another part is ports. So it is running, it is going to exhibit the port in TCP, and port is 80. So this is actually the port the service is going to run. This is the target port, which is where your pod port is running. So that means here YAML, you are telling the container is running on port 80. That's what I am forwarding the port to 880. And also it is not required both should be the same. It can be different. Sometimes you are running MongoDB, so your port might be 2, but still you can put the port 80 to forward the request to this. Okay, so that's what the service YAML file, and still you can put many things in the service YAML, but it is a minimal configuration to get our work done. So I'm going back to that thing. So I'm going to create the service using kubectl create -f /vagrant /configuration DIMusic service YAML. So I'm going to create the service by hitting enter. So what is telling? I think that I already ran the services. I'm going to delete it. Kubectl service, so delete service DIMusic YAML. So I have deleted. Now I'm going to run the same command. So now it is telling service DIMusic YAML created. That's perfect. So let's see, go and see that things, how you can access the service. Kubectl get services or SVC. So you can do the both. You can see that DIMusic YAML service is ready, and it is running the cluster IP, this one. So this cluster IP is only it will applicable, and it can accessible to internal to the Kubernetes cluster. Right? So it is not accessible outside the world. That means if you are trying from your Google client itself, it will not accessible. So you can see that, check it, called HTTP. So you will not get any answer back, because this cluster IP will not be resolved. It is only resolved inside our Kubernetes cluster. So how to check it? So we need the interactive cell to check it. You need to go inside the pod and you need to check the cluster. So I have an idea to do that. So for that, I'm going to use BusyBox for the interactive cells. It is a very minimal image, so you can play on all the commands over there. And so I'm going to use it. So until now we have seen to create the resources using YAML file. That is correct. We are using YAML file to create the resources, but there is another way to create the resources and control the resources. How you can do it? You can use kubectl run command. So this run command can run service, can run replication controller, can run pod, can create the services, can create deployment, everything you can do it. So I'm going to run using run command. So I'm going to name it called my terminal, and I'm going to use -i is there for interactivity, and I'm going to use TTY because I want that console terminal back to me once that pod is actually deployed. And then I'm going to mention image equal to BusyBox, and also I need to execute the command bin/sh because I need that shell script only. So I'm hitting enter. So it is trying to create the pod, and when the pod is ready, it is going to give back the terminal to me. So yes, we got the terminal. You can, so now you are in that, so you can see the ls, you are in that Linux box. It's a pod, it is, you are inside the pod of the busy box, Linux box. Now I can try the same command, because whether you can see whether it is resolving this IP or not. So you can see that I'm hitting it at, oh, here curl is not found. It's because it's very minimal box. I can use one thing called wget. Then I can use that output to index.html or something, because it is actually a Nginx HTML Angular 2. So I'm going to use index.html as a name. So I'm hitting it. So I got that things. I got that some binaries. So go and check it. I'm going to use cat and index.html. So I'm hitting enter. So yes, you can see that there is a DIMusic company, which is the same HTML which we got in here. So this is the same YAML which is running inside, and we are able to access using cluster IP of the service. So that's the beauty of the service. And so, and also it's not only a cluster IP, you can access in via DNS resolution, via that using a kubedns. Kubedns actually, it is a name resolver and as a name resolution server. So now we are going to use, instead of like IP, so I used IP, correct? So I used IP instead of IP. I'm going to use some naming conventions. So my service is running in the name of called DIMusic -YAML, correct? This is the thing. So whether it is going to resolve my thing or not. So I'm going to tell it is called index1.html. Yes, it is accessible. So I can see that cat index.1.html. You can see the same web page is here. So it is resolving by a DNS name also. It is a proof. So that's the beauty of the service. Even I'm going to tell that some other naming conventions. So what is the naming conventions? So your service name should be first, then next is your namespace name. So we are running a namespace called default, because we don't have a separate namespace which we created, default. And then what is the type of the service? This is actually a service, correct? That's what it's SVC, then and cluster and .local. So I'm going to tell that it is called 2. Still it is working. So cat index 2.html, you have the same web page. So that's the beauty of the service. So you are able to access your service using DNS names as well as cluster IP, correct? So this is excellent. So if you are running a lot of microservices inside your cluster, it can interact each other without knowing the IP of each pod, and also it is acting as a load balancer. For example, if you run 2 or 3 pods or even thousands of pods under this pointing to this service is going to distribute the load across the pods. So that's the beauty of that service. So it is acting as a load balancer as well as it is acting as a name resolution, having a name resolution, awesome name resolutions. So now I'm going back to the terminal. So I am done with that. So now we have seen it. Okay, fine. So we are able to access inside the cluster. What about if my application is front-facing application and also user-facing application? So I need to access this application via internet. How I can access it? Correct? So that you can do via external service IPs. So that's another thing. So that you have to mention in a very clear way. So how to exhibit. So in Google Cloud, there is an option called load balancer. So even though the service is running load balancer internally, I want to access the same thing with the external IPs. How we can do it? you can achieve via the same thing called same thing. I am using the same YAML file, but here I am mentioning type equal to load balancer. Correct. So if you go and see that kubectl get svc, you can see that so cluster IP only is selected, there is no external IP. Correct. So now it is very problematic because you cannot access this into the internet. So I am going to deploy another same application in the different name, and I am going to mention this IP name. Okay. So how I am going to do it? So see it. So I am going to I'm here this time. I am not going to use YAML. I am going to use kubectl run. So kubectl run. I'm going to name it called DIMusic web. Correct. And then I'm going to tell image name equal to gcr.io slash nitya io demo slash DIMusic web. Correct. This is my image name which we have pushed into that Google Container Registry, and I'm going to put some labels also, and that label I'm going to tell that app equal to DIMusic app and version equal to 1.0 or v1, whatever you want to do it. And you can tell that anything, and you can mention environment equal to production. So whatever you want to do in the labels, that's very important to maintain the label because it will help you in future to fetch it back. And I can use -hyphen port. I'm going to mention that port is 80, correct, which is running in 80 only. So I'm going to hit enter. So it is going to create a deployment called DIMusic web, and it is going to deploy my image as a pod. And sorry, I think some mistake I am doing it. Let's see what mistake I am doing. Docker run DIMusic web image here. Okay, sorry, I mentioned wrongly with prot instead of port. So I'm going to use port 80. Now I'm hitting enter. So there is a small spelling mistake, and my deployment has got created. Correct. Now you can see that how much easy without this YAML file, but it is not scalable more way to using this kubectl because it is easy. It is not easy to change and everything. So you can use it for demand purpose. So kubectl get deployments. So you can see that DIMusic web is deployed and it is up and running, and it's up within 30 seconds. So now I'm going to expose this as a service. So it is very easy in kubectl's run. So I'm going to use kubectl expose command, and what is the deployment name? Expose deployment. So I'm not going to use this YAML file to create the external load balancer. So I'm going to show how to do it, and you can use the same external load. So it's the same effect will happen. Kubectl expose deployment, and I'm going to tell what is the name of the deployment, DIMusic web, because that's the deployment name, and I'm going to use --type equal to load balancer. So if I hit enter, it is going to create a load balancer and you can access your application externally from internet. So I hit enter. So you can see that your service exposed. It's exposed to the world. So let's see. Kubectl get services or SVC. So you can see that now it is trying to create the external IP. Previously it is not trying to create, now it is trying to create. So it will take a minute or half a second, half a minute, because it is going to spin it, issuing external IPs. So the external IP is nothing but you can see in your container engine, and go to here and networking, and you can see that some of the external IP is getting provision over here. So that's what actually it will reserve that IPs for us, and that's what it is going to use, one of the IP from this pool. So let's see whether it is created or not. Yes, we got the IP. I hope it is already provisioned with 193. See, this is actually, you can see that there is a IP which is created for us. So now take this IP and go to this internet and hit enter. Think we have missed something. It's already up. See, I found the issue. So DIMusic web is decided as 1, current is 1, up to date 1, but it is not available. I think there is some issues are going on deployment. Let's see. So I'm going to use kubectl get pods. Oh, this is the problem. So it is having a problem called image pull back off. That means whatever we have deployed and that image is not available in GCR. So let's see what command we have given while thing is. So the image name is gcr.io/nithya. Oh, sorry, there is a spelling miscall. Nithya, correct. Nithya IO demo and /DIMusic web. Oh, we have missed that the version over here. That's the problem. So a small mistake happened. Sorry about that. So I'm going to delete the deployment again. I'm going to is the same command, kubectl delete. These are a small silly mistake will happen if you use this command line tool. So that's what you have to go with the YAML file. So it's a very good experience. Kube delete deployment DIMusic web. Okay, so it is deleted. So I'm going to see that pod should be removed, correct? That pod is got removed. So we have a old pod only. So I'm going to use the same command but with version now v1. So hit enter now. So now go and check that get pods. Yes, now this time it is in running states, and even you see the deployment kubectl get deployments. Now this time is available. So that means, so previously we had a problem with that version. So please keep in mind, please mention the tag properly. Now, and so since I already have the services which is running, so now go back to this and click it enter. Awesome. So now it is resolving. So via the service names. This is the beauty of the service. So you are able to see your application outside internet, correct? So it is equivalent to which is running locally. You can see this is a local host. This is resolved and from that cluster external IP. So that's the beauty of the service. So we are able to spin the machine and we are able to create the service. We are able to resolve that all the things via the DNS resolution, and we are able to access from the internet. So that's all for the session. So we had a very beautiful session today, and let's see in another beautiful session explaining much more about Kubernetes cluster. Thanks for watching. Much appreciated your patience. In this video, we have understand more things about what is Kubernetes dashboard and what is called deployment, how to use a kubectl for deployment as well as controlling the clusters, how to delete the resources and describe the resources using kubectl, and also we understand more about services and how it can act as a load balancer as well as how you can access the services via DNS names. All the things we have seen it, and it was very interesting and much appreciated for your patience. And if you want to access the source code, you can access via github.com/nityananda/kubex. And also I'm suggesting to please sign up that newsletter from website nitya.org/sign up. And also please send any feedback or advice to my email ID info@nitya.org.